Hello everyone. Today our first class for relation and function lesson. We have already discussed relation and function in our 11th standard class. So we just revise it once very fast. What do you mean by relation? First we, in the word relation, we can say relation of brother and sister, relation of father and son. Similar way we can say so many relations. That is our daily life relations. But in 11th standards, the second chapter, we learn the relation of maths also. Okay, so which type of relation you learn in 11th standard? Suppose you have given order pair A comma B. What do you mean by order pair A comma B? Means there is a relation between A and B, something that what is mentioned here, suppose I say B equal to A plus 1. So what is the relation between A and B? That B always one more than A. So this is the relation of A and B. So this type of relation we will learn in this class. Okay, but I have written order pair. What do you mean by order pair? We already discussed Cartesian product in our set theory. So if I write A cross B by capital which I have written, that is your set. And if I write order pair A comma B, so you can say in Cartesian product means your element A lies in set A and element B lies in set B. This type of things we already discussed in 11th class, second chapter. Okay, this is the relation. But now what is function? That also we have discussed, and few more things we discuss in 11th standard. What is it? Function we are mentioning by this way, A to B. F stands for function. This is your domain and this is codomain. One more word you learn in 11th class, that is range. Okay, fast we discuss this 3 points one more time. Domain means suppose I mention function from N to Z. So in domain we are considering all natural numbers. Codomain means we are taking Z. Now what is range? Suppose you have given function as a x plus 1. So we have to start putting elements from domain. Domain is n. So natural numbers start with 1. So 1 plus 1, that is 2. Second element 2. Natural number, second natural number 2 plus 1, 3, and so on. We can go. So what you get as an answer? That is called range of f. Range of f can be mentioned by capital R and small f, and that way we can mention. This is I have written by which method? Listing method, or you can say roster method. But if I want to write by property method, then how can I write x oblique? X belongs to n minus 1, because we haven't taken natural number 1 from natural number 2 up till n. So all the natural number is considered, but 1 is not there. Okay, both the method you already learn in set theory, that is listing method and property method. Now domain is clear to you. What is range? Range always lies in your codomain. So domain we are mentioning by du of f, and if we have taken a or n or whatever, then codomain, that can be written as directly codomain, and it is as a z, or we can say here we have taken b. And range of f, capital R and small f, that we have written both the way, listing also and property method also. All these things we have already discussed in our previous classes, 11th standard. Now we come to the point, your first word relation. So today we discuss about relation only. First we discuss two extreme relation. Two extreme relation. What is the relation, extreme relation? One is empty relation and second is universal relation. Now from this word you can understand that empty relation, a relation in which nothing is mentioned, so we can say empty relation. But we don't get it that if it is relation, then how can we say empty? So I give you one example. Suppose you have given set R, boys school, in school all the boys. So set R mentioned boys of full school. Now I take one set A, that I take X. What is your X? X is difference of ages, difference of age of girls of school. What I have taken? Set as a difference of age of girls. Now it is our boys school. So if I take difference of age of a boys, then we can say it is a set. But here we have taken difference of age of girls. So it is not a set, or you can say it is a empty relation or empty set. Okay, now just we take same way one example. One more example we take. Suppose set R is mentioned all natural numbers, or you can say natural numbers union 0 also. Okay, now I take one more set X. What is your X? Difference of age of students. Difference of age of students. And if we have taken that set, in set all the natural numbers and 0 also. So all 1 to n. Now when you take difference of age of student, so if you take, suppose the school from nursery to 12th standard, nursery to 12th standard. So if we take one student of nursery classes, maybe the age will be 3, 12th standard, so age is 18. So your difference will be maximum 16 or 17 year. So if we consider that, so you can get, suppose same class student you consider, then you get 0 also. If difference of any two other different classes, 11th standard, 12th standard, then 1, 2, so on. Means here what you get, that is our universal set, that you get all the elements which are the difference between these two. But if I take that the difference of age of a student is 100, can we get this set? Check. If you take difference of age, then definitely your difference should be 15, 16 or 17, 18, maximum 18, 19 year, but not 100. So this relation is said to be empty relation. But if I use here word that X is the difference of the age of a student less than 100. Less than 100 means now it is your universal set. Why universal set? Because less than 100 means you can consider from 0 to all numbers. So we get in universal set. But exact 100, then we get the empty set. Now these two relation, empty relation and universal relation, this is the extreme relation. Now we will discuss another type. Now what is the definition of extreme relations? So first, empty relation, a set which has, or a relation which has no element, and universal means all elements. If you write in notation form, then R equal to, suppose we are writing A cross A, means relation will be mentioned if it has no element, means empty. And if in relation, if you get all elements, then you can say it is universal. Means empty and universal clear, these two extreme relations. Now we come to the main important topic of your 12th standard classes, and this relations type of relation is too much important as far as your JEE concerned. First relation, reflexive. Now reflexive relation. Now you tell me, reflexive word. What is shows reflexive? Means reflection. I give you one simple example. Suppose we see in our mirror. Then what we say? What we see, our face only. Means relation of, suppose we are mentioning by small a. Then our relation with ourselves only. Why? Because when we see in a mirror, we get our image only. So relation of the person with itself. Suppose my name is A, my mirror A, image is also A. So this relation can be mentioned by A comma A. Relation of a person or a term with itself. This can be mentioned by relation mentioned by capital R. Relation of A with A itself. You can write by this method also, you can write by this method also. So reflexive word only itself shows that the reflection, and reflection means the relation of a person or a term with itself. Okay, let's take one example. Suppose you have given one set A in which you have 3 elements 1, 2, 3. Now we are taking one set A in which 1, 2, 2, 1, 1, 3, 3, 1, 2, 3, 1, 1, 2, 2 and 3, 3. This much element is given. Okay, this is your set. What is our relation? What is the term is given in set? 3 elements, and its relation I have mentioned here. Now check 1, 2, 2, 1, 1, 3, 3, 1, 2, 1, all this. Now what I explain you in reflexive relation, that the relation with itself. So check here, relation of a 1 with 2, 2 with 1, 1 with 3, 3 with 1, 2 with 3, 1 with 1, 2, 2, 3, 3. Means here we have 1, 1, 2, 2, 3, 3. So this relation is called reflexive relation. Why? Because we have here 3 elements, and all 3 elements are there in our set. So this relation is called reflexive. Let's take one more example. I take this same example, but just we change the elements. Suppose we have set A. Let's take 1, 2, 2, 3, 3, 1, 1, 3, 1, 1, 2, 2. Now check. We have 1, 2, 3 elements, that is same. We have 1, 1 and 2, 2. But 3, 3 is not in set. So what is the meaning of it? Suppose we have taken this is set A and this is R. So 3, 3 is not in R. So this is not a reflexive. So now what I have written, that is in a listing method. So it's very easy for you to understand. Now let's come to the property method. Let's start with property method. First I give you one example. Let's take set A as a natural number. All natural numbers I have taken. Now what is the relation we have taken? That A oblique, either we can say relation of A comma B, where A equal to, or you can say B equal to A plus 1, and your A belongs to N. This way set is mentioned. Now you have to check, is it reflexive or not? Okay, let's start with reflexive first. What is the, if you want to write the order pair of it, then what is the easier way? Natural number is given, so you have to start with 1. So where your A is 1, then what is your B? 1 plus 1 will be 2. When I take A as a 2, then B will be 3, because I have taken one more. Now check, do you have 1, 1, 2, 2, all these elements is not in R. What is the meaning of it? This is not a reflexive relation. Okay, but this is for your understanding, I have written like this. But in exam what to do? You have to write in the same format only. So A comma A is not in R. Not in R means A comma B. Why A comma A is not in R? Because B is one more than A. So naturally A and B are not same. So what is the meaning of it? Then if you get 1, 1, 2, 2, 3, 3, all that terms in a relation, then only you can say it is a reflexive relation, otherwise not. Okay, let's take one more example of a reflexive relation. Let's take set A as a natural number. Now I take one relation R in which we have taken one, either let's take with A comma B, A comma C, A comma A. We are taking here ABC only. We make it shorter question. Then B comma B. Then let's take B comma A, C comma B and all. Now check. Is it a reflexive or not? AB there, AC there. AA is there, BB. This one is BA and CB. But here we have one more element C. What is the reflexive relation A with A? Means relation of A comma A in there, A is there in R, B comma B also in R, but third element C comma C is not in R. What is the condition? If two are there but third element is not there, then also it is not a reflexive. For reflexive, whatever the elements are given, all elements relation with itself should be there. Then only you can say this is our reflexive relation. If I have added one more element here C comma C, then you can say that C comma C also in R. So it is reflexive relation. So I think reflexive relations, 4 questions we have discussed, 4 solutions. So it will be more clear to you. Okay, now come to the definition of a reflexive relation. What is the definition? That definition can be written as, suppose your element A in your set and the relation of A comma A in R, then this relation is called reflexive relation. Okay, now same way reflexive relation we have to learn about symmetric relation and third one transitive relation. We have to learn about these 3 relations. First one is I think more clear to you. So now second and third relation, symmetric and transitive, and its example we will discuss in our next class. So just reflexive relation is I think more clear to you with example. Thank you.